Thank you so much, Yavor. Yes, I want to start maybe first by a few words about myself. So, yeah, my name is Victor Botev, and I'm the CTO and founder of Iris.ai. And what we do is we build products for researchers. We help people that work in innovation departments in big companies or smaller ones. And essentially, we use them. We allow them to utilize AI tools in order to be on top of state of the art, find the relevant literature to their research, also implement new products, build new materials, or just simply look at what the competitive landscape is for their particular company or for the products that they're building. So the talk tonight will be about personalized AI assistants, and we'll focus more on their web part and how the web and web interfaces will change in the future. As already said here, that's a talk that we presented at the GTC conference that is held by NVIDIA. It received actually very good feedback, so I hope it will be interesting for you. And yeah, let me know if you have any questions or if you have any feedback or comments about that. Yeah, moving forward a bit. So yeah, I already said a few things about Iris.ai, but one of the things that we're focusing these days is how to change the way people interact with web applications. As of today, we have a web platform that's called Research Workspace. It has a lot of things that you have to click and do. It's intuitive, but still takes some time. And we understand that with all this boom around AI and LLMs, things will change. Maybe I'll start first with a few words about LLMs. So all of you have used ChatGPT and chat-like tools. They're like coming more and more into our day-to-day life. Even, I mean, most of the web applications today have some sort of chatbots. But one of the issue a little bit with the chatbots is that, well, they're chatbots. So what I mean here is that if you remember back in the days, there's this IRC interface where basically a lot of things related to computers happened in this kind of chat-like interface where you find people and talk with them. And here with this chat-like interfaces, we're returning back a little bit to these kind of interactions where you kind of type things, you get responses and stuff like that. But the reality is that within the last few years, things have changed a lot. Like we are now using other type of chat interfaces. And not only that, but we are able to like share documents, click around, interact. We do API integrations and stuff like that. So essentially, one of the things that we did, for example, before preparing this presentation is that with my co-founder Anita here on the bottom left corner, we more or less collaborated together in order to build this presentation or to build all the demos that were necessary for the GTC conference and stuff like that. And this collaboration is the key to some extent of how people do innovation. So we need to find ways of people to collaborate together while using tools like ChatGPT or other LLMs. But not only that, we need to figure out how people to interact in different ways, also more visual ways, because that's one of the ways in which we interact with the real world in a way. So a few things about interfaces here. So when we talk about web assistants, the reality is that in your phone, you have assistants for quite some years now, maybe more than 10 years. You have heard of Alexa, Siri, or others like that. And but you don't have these things on the web. Why not? Because you can easily interact. You can click things around with this amazing mouse interface and things like that. And the question is how can we do the same type of interactions with our LLM and how it can help revolutionize or change the interfaces themselves. So the way we see these things is that you need to be able to more or less automate a little bit the things that you're doing today. So, for example, you go to a particular website, you click this particular thing, then you go somewhere else, but you do that on a day-to-day basis, especially if you use particular applications or platforms. So you can tell your chatbot, hey, I did these things, can you just record it? And then I can click and do it. The other thing is that if you ask the chatbot to do something for you, so you can tell it, okay, so let's say in Iris Research Workspace, you can say, I'm working on this new amazing material. Can you gather all the information about it? And yeah, so it can interact with the API to the Iris platform. It can build it for you and give you the answer and say, yeah, here is your data set, this is the answer. Well, but the problem with that is a little bit that you lose the interaction. So if the chatbot at that point has made a mistake, you cannot see where the mistake might have happened. So you have to go and inspect the whole data set, inspect the answer, check things out, especially if you're a researcher. You don't want to have any hallucinations in the results because you're going to the lab afterwards and spending like $500,000 or producing this particular material. So you definitely don't want to make a mistake. So you have to basically go and inspect that yourself. And then the researchers say, well, actually, that inspection takes more time than if I go and do it myself. So then we said, okay, so maybe there's a better way of that. So maybe actually this interactive web assistant can go and click things for us so that we can see what it is doing, so that we can continue the process where it left off in a way. So basically, in this case, it will go and not only call the API, but also show you the visual results of what happens, what kind of, for example, in our particular use case for data sets, what kind of filters it used, what kind of similarity metrics, and all of these things. And you can spot already if it did something wrong. So then you can go yourself and either give direct feedback to the chatbot and tell it, oh, actually, can you use this other filter because the one that you use right now is not the best option. Or you can go and fix it yourself, but you know where to touch. You don't need to do this whole inspection that otherwise was inevitable with the current direct, more or less, answer here. Then the second thing is that, and I think that the guys here with Team-GPT work a little bit on these things, the ability to collaborate and together use chatbots and chat-like interfaces. The next idea is that you're able to together more or less ask questions, ask not only for questions, but for interactions as well, and record those interactions for later. So for example, if someone asked already a particular question, he's satisfied with the final results, with the artifacts that are built and so forth, you can just click and say, yeah, save this workflow for other people. And then you can ask that when you ask the chatbot the same question, it will always do the same thing. It was verified, and it can be used by everyone else in the organization. So this can, at least if you really need to do the inspection, you can do it once, and then everyone else will be able to more or less use that again and again. What else? I think these are kind of the main issues that we saw from our clients, and why the adoption of tools like ChatGPT or the likes is quite high with researchers, because they find it very difficult to assess whether the response to their answer is actually real or is it hallucinated. And even if they get references, because right now some of the LLMs actually provide references, including our own chat tool, they are still unsure. They want to go and check themselves some stuff. And yeah, I mean, in reality, when we measure the time, we see that if they go and do the checking, they really lose like half of the benefits from using those kind of tools. So we need to help them do that. But I believe this is not only for researchers. I think this can be very interesting for other areas as well. One of the biggest proponents of this idea of interactive web assistant, and basically we call them also demonstrators, because they demonstrate you what to do. They do it for you as well, so you can just watch. But one of the biggest proponents is actually Mustafa Suleyman, and he will have a very interesting talk this summer in San Francisco, exactly about this topic of interfaces and what innovations are upcoming, and how the current more or less static websites will turn more into videos, into demonstration platforms where LLMs will have a very, very big part into that. And of course, we are also expecting new multimodal models that include video, images, and stuff like that to play a bigger part as well. So going a little bit more deeper now, after talked about interfaces, one of the important things, because the topic of the talk is not only about assistants, but also about how to personalize them. So Gen AI technology is great. We have seen everything that has happened today. But one of the clear learning in this year and a half for now is that domain tailoring is still very important in order to achieve very high results and have business quality applications, more or less. What does it mean, domain tailoring? It means that you want to fine-tune or modify the LLM in order for it to understand better the context of your concrete domain. And a lot of people, when I say domain, they think about very large domains like medical or something like that. No, I mean, we're talking about the specific domain of a concrete company, for example. Some challenges and why this is needed, I can list a few, is, for example, when we talk about companies that produce new materials, they work with chemical formulas. Chemical formulas can be expressed with these very strange strings that we all learned in chemistry classes, but they also can be expressed with standardized formats like SMILE chemistry format, or by some sort of images where you have connected chemical elements and things like that. And these things are not very well captured by the general models, and they probably shouldn't be, because with the general model, we want to talk like regular language, and this language is slightly specific. Similar thing is, for example, for DNA sequencing when it comes to genetics. Like then you have these long DNA sequences that mean certain things. You have protein sequences and other stuff like that that take a bigger part of the actual document, and the LLM is not making that much sense of it. So we need to kind of tailor it a little bit to that particular domain. So the first step to basically start personalizing the LLMs is giving them more or less this ability to understand the concrete domain. That usually happens with fine-tuning, but we'll talk a little bit more about that. So the second thing is to more or less tailor the LLM to particular topic or question. What does that mean? In particular industries, we have certain types of questions that are more common, that people will request, for example, give me top 5 materials, or things like that. So you already know that there are certain types of questions that are more frequently asked, and they're much more interesting and give much more value to the users. So you want to somehow tailor the model to that. And here you can even do that without fine-tuning, but just modifying or tailoring a bit the prompts so that the users don't need to worry about that when they're asking the question. So they don't need to tell you that, oh, and please format it in this way, or focus on this particular thing, or be very expressive or less expressive, be precise, don't tell me things that you don't know, and all of these things. Some of them even fall into the category of what people call today guardrails, because you don't want, for example, to have hate speech sometimes. You don't want to have some other kind of malicious artifacts into the final results. So that's kind of the second step. So you have first going to the domain, second going to the concrete use case or application, and the third one is actually the personalization. I think that's the least developed part today about this kind of interaction. What does it mean, personalization? It means that the chatbot should start adapt itself to the way you speak, the way you reply to it, and get to know a little bit what's your understanding of the topic, so that it can describe to you the topic in a language that you understand. So essentially, for example, if you have only basic understanding of chemistry, it should always explain you answers in chemistry on a basic level without going into too much details or too much specific terms, because you would not be able to understand, or if it has to go there, it has to explain the term so that you know what it is talking about. And this part is a little less developed today, but we believe that will be really powerful in the future. And we already see certain companies, especially in the educational sector, that are moving more into this direction. Because, yeah, I mean, you understand that people learn differently, although the current educational system is much more focused on general knowledge than on each individual's ability to understand it. But these things will change in the future, and the AI technologies will help that. So a little bit more examples maybe here from our experience with Iris.ai is we work with this Finnish Food Safety Authority, which essentially is the governmental agencies that checks how safe the foods are. And why do they like so much our tools today, and why do they crave so much for personalized assistance? Is because, well, they have this job that they have to understand so many different angles about the food. Like, for example, for each and every vegetable and fruit, what kind of pesticides were used, where was it grown, what was the pollution levels there, how does that affect the final product and things like that. What kind of refined products are used in the foods, how are they produced, how are they manufactured, and all of these things, they need to be on top of that. And all of these different areas of the industry, they're developing independently, and they're developing into different directions. So if you're an officer there, you have to have some understanding of each and every area. And today our tools are helping them a lot, because they're able to kind of connect all of these things, which otherwise are not very well connected in the research world in general. But what they're saying is, I still need to dig so much deeper sometimes to understand a particular concept, and it might take me months. And at that time, they already changed the way they produce the particular food. So that's really a problem. And if they had a personalized assistant that can explain to them this thing on a level that they can understand, that can save them a lot of time, and at the same time make the output of their work, which is essentially the report of how safe things are for our health and so forth, much more useful for the time today, and not for the time 2 years ago. Or something like that. And because, yeah, I mean, the reality, because we work quite closely with those guys, is that really they can assess things that are on the market for a year. And for that year, some bad things might happen sometimes. So what are some of the remaining challenges today in order to kind of bring this AI technology to be super useful for these kind of people, like the Finnish Food Safety Authority? So one of the things that I'm going to talk more about, because that's something that we work quite deeply at Iris.ai about, is how to address hallucinations and factual misconceptions. There is like a very kind of tiny difference between the two. So factual misconceptions are essentially when the LLM is taking properties or behavior from one entity to another. They might be similar, but not the same sometimes. So because the LLMs are good at generalization. So for example, if you ask ChatGPT, or at least the time when I asked it, is vanadium a good conductor of heat and a good conductor of electricity? The answer would be yes on both, because it's a metal. And then the LLM takes the properties for the metal to the vanadium. But vanadium is actually one of the exceptions that's not so good conductor of heat, for example. And hallucinations are things that are basically invented. They are not in the content. They are completely new. When it comes to our area, which is research, some of the main areas of hallucinations are inventing new numbers, or inventing new processes, or new locations, or things like that. And that could be a problem. Like if the LLM tells you that you can produce this material, and then you can transport it from point A to point B easily, because it can totally work fine at room temperature. but in fact it has to be at minus 130 degrees, then it's a problem. Actually, that's a real use case. So there is a laboratory that actually asked ChatGPT for a question about a particular drug, and it told them totally that you can transport it at room temperature. And the moment they received it, they got this little letter from the producer that, yeah, be mindful, this have to be kept at minus 120. So yeah, so these kind of hallucinations could be quite costly. Of course, I think it's a little bit of a mistake on their side that they didn't check these things, because I mean, ChatGPT is great. I really liked it and use it for a lot of things, but I also like take some stuff with a pinch of salt and check them because yeah, this could be a problem later. So how do we mitigate hallucinations? So more or less, here are three basic ways in which we think about that. So first thing is integrating structural knowledge. So I mean, I think for the last like 6, 7, 8 months, there has been a lot of work in research of how to do that. But essentially the idea is that we have built for the past like 30 years, like tons of data that's structured. Like it lies in some databases, it lies into some sort of like relational databases, non-relational databases, graphs, whatsoever, ontologies, files. We have it structured, we know what it means, and we know that it's there. And right now we are kind of avoiding it because we can express everything in native language, and we have all those documents that also contain it, but they're unstructured. So, and since today at least, these models have issues a bit with the facts because they try to generalize on them. As I said, like for them, 20 and minus 120 are just numbers, and statistically they might be similar in appearance. So they don't know what to put in there. So then integrating structured knowledge is something that can help in this situation. So if you know that this is the structured knowledge and you kind of instruct or embed this knowledge into the LLM during the execution of the query, then you might get better results. Second thing is high quality data. Here, I really like to explore more the new model from Microsoft, the Phi model family, because they started this following on this idea, what if we train these models only on like textbooks and very structured knowledge in a way, and turn it into a model. The first models were good, but quite limited. I think the new ones, though, are pretty impressive. So I hope that in some presentation in the next months, we'll probably can give you some more details about how those works, because we are actively researching them today and evaluating them. And the third thing that we can do also is to try to embed some sort of reasoning guidance. Like one way of doing that, we probably have heard that, is like some sort of multi-hop query where you ask several questions to the LLM, let the LLM evaluate itself and so forth. Here we are taking more the approach that we have some sort of structured knowledge that we use as a guidance for just one hop answer. So we directly embed it into the context and into the prompt, and then we get the final result. Of course, the other option is also not bad, but it's a bit more expensive because, you know, every call to the model actually costs money. Yeah, so integrating of knowledge graphs. Here you can see one of our knowledge graph types. Here there are certain chemicals which have certain properties and so forth. Everything looks nice with knowledge graphs, and they're actually quite easy to inspect by humans when they are small. Like when you enter into a graph that has a couple of million vertices and even more millions of connections, then things start becoming a little bit obscure in a way. But still, how can we use this amazing graph that we saw in order to help this LLM to actually do something useful for us? And here it's there are a few areas in which this can be done. So first area is that you actually can generate, I mean, I talked a little bit about this high quality data, but you can generate synthetic data that's quite, yeah, basically it's high quality, it's on spot, and it's diverging or different than what you have today. So you can take an example here, like these metals are good conductors of heat and electricity. You can more or less multiply this statement by each and every metal that actually has these properties, and in this way multiply the knowledge about each and every metal there. Another thing is trying to insert facts inside sentences that are about the metals. So for example, you know something about the room temperature, at what temperature the heat conductivity happens, or you know something about the pressure at which things are done, or so forth. Then every sentence that actually mentions that, you can kind of enrich it with this information to embed more and more facts. So why is this good? Because when you embed those facts in sentences in connection to these particular entities and not to the parent one, which is the metal, actually increase the statistical probability that the model will give you exactly this number, like 400 there for the pure copper, than any other number. Because if it doesn't appear there, but it appears close to metals, or it appears in sentences with other metals, it will have, I mean, this probability will be equalized by the other metals, it will be equalized for all metals, and it will be generalized by the model. And at the end of the day, you would not receive what you are expecting. I must say that with this kind of approach, you can improve the ability of the model to generate the answers on the spot, but it's quite tedious and requires a lot of data and yeah, quite some resources to actually fine-tune it, because the model has to actually go through that. But it works, and it definitely gives results, but it's a bit costly. So then in this situation, we might actually want to do something slightly different, which is trying to guide the LLM just by going through the prompt and changing the prompt itself. So, for example, here we have this question, how to increase the toughness of steel materials at low temperatures. And then we have some sort of initial answer here. But what if we help a bit the LLM by showing the LLM what these structures or entities that the question is about are more or less related. So here we have a very simple graph that tells us, okay, so we have a compound, we have a property, and we have a condition. And we tell the LLM to kind of follow the graph structure, which most of the big LLMs understand pretty well, which means that, yeah, you can see the intermediate answer. I created the graph and found the property toughness and temperature with value low and so forth. So it kind of follows the graphs and tries to understand what you're asking and fitting what your question was into these categories, which after that allows it to reply the real answer. So on the previous slide, basically we have here alloying elements like nickel, which is very general and doesn't give us the real answer. And here you actually have the three types of materials that you're interested in, because the model has identified the things that it has to focus on during the query. So this method has proven very powerful. I mean, this chain of thought idea have been introduced, I think, last September or October. After that, there have been follow-up research articles on tree of thoughts. Then after that, there are a few more articles that follow up, even thinking of how to do this on a multi-hop level. Here, of course, this intermediate answer doesn't need to be seen. I just instructed the model to produce it together with the answer. So it can be totally hidden and you directly receive the answer. This is one hop. But you can do pretty interesting things when you try to put the model to traverse over the graph while it's doing other stuff. Today, people are also introducing rack on top and querying the graphs, then querying the texts and combining things together. So a lot of interesting things can be done with structured knowledge, and we are also improving the way we're working with. But just this simple thing, like just a very simple graph with, as you see here, like 3 edges and 2 connections, can improve the results of the answers a lot. And I'm pretty sure that for very specific applications, you don't need to have a very complex graph schema and stuff. Yeah, a question?
Is graph specific for each question, or is it just something general for this type of questions? Or like, do you do question processing when you put the graph inside?
Yeah, so the graph here, it's actually a domain-specific graph for this particular client. So for every client, more or less, we prepare the graph structure, so it's common. But when we do the questioning, we actually query the graph and we identify which areas of the graphs are related and we feed them into the LLM. So in this particular case, it's just this simple 3 things. But if you have like a full paragraph question and not just one simple question as it is here, it can actually extract more entities and more connections that are relevant, and then the prompt will be different.
So then apart from this thing, you also have logic that extracts a graph based on the question.
Yes, exactly. I mean, you can fill in the full graph if you have enough context, but that's a different story about the context and how to fit things in. But yeah, so in order to simplify things, it's better to actually query the graph and identify the entities. Separately, you can also train smaller models to do that based on LLMs, which are actually quite good at extracting such types of entities and relations from text. I mean, you can try both GPT models and Llama models. They're pretty good at extracting information in such a format. Like if you tell it what are the interesting entities and what are the relations, it can do that pretty well. Of course, GPT-4 is probably the best in that. But the good thing there is that you can actually build a synthetic data set and then train a very simple models that can do that from your graph, essentially. Yeah, moving forward. So yeah, as I said before, one thing is to do the tailoring, where we try to tailor a model to a particular domain, to a particular use case. But then when it comes to the personalization, it's important to actually focus on the concrete person. So basically, the idea is that when you ask something that is related to a particular person, let's say that we are 5 people interacting with ChatGPT, and you want to ask him, okay, so what did Peter, let's say, do in this date, or what kind of or how does he make cake or whatever. The model should be able to like recall this information and somehow relate or personify each and every person. So here this a little bit relates to the generalization of models and the entities themselves, that the particular person has to be an entity, it has to have certain description, facts related to it, and so forth. But the reality is that when you start interacting, you most probably don't have those. So then you have to build them. And so the way we believe this can work is that the model itself should be able to interact more or less with structural data and structural databases and start feeding in the different facts about the different people or different places that were mentioned during the conversation, and more or less have some sort of long memory. I really liked actually that in Claude and in GPT, they're thinking about long memory for quite some time. They're introducing new stuff there. And I expect that something like that will be available probably this summer or a little bit after that, when it comes to the ability of the model to follow very long conversation and store interesting information for entities of interest that you don't need to specify necessarily directly, but it will infer them in the same way that it's able to infer now entities for graphs and stuff like that. It is not there yet, so if you want to do this today, you have to gather this information in your own fashion. And unfortunately, there are lots of regulations, so you have to be careful what kind of information, where you're storing it, and things like that. That's why I'm more waiting for the big players to do that, because then this will somehow be okay, or weaved into some sort of encoded knowledge that people could not easily have access. So you cannot be kind of liable for storing some sort of personal profiling information. But at the same time, having this knowledge about, let's say, how Peter makes cake, or how certain materials are made and things like that, helps a lot in this endeavor of trying to explain a complex knowledge to a person that doesn't have that knowledge. Basically, that's one of the issues in both the educational system, and the more you go to, let's say, science, the more difficult it becomes. That basically the knowledge is structured for most people to understand it, but then when you go to very deep science, you actually have these very specific concepts that very small groups understand. And now if you have to explain it to another person who is building the product or that, or if they're like 5 different research groups that have to talk together, then things become difficult, because each and every person need to understand the context and so forth. And humans, it takes them a lot of time to do that. And I think LLMs here are very good at this. They will be able to translate basically the complexity of one group's language, let's say, to another one. And when I say language here, I mean even the scientific terminology, the scientific understanding of particular concepts and so forth. We have already seen this with the Finnish Food Safety Authority. When we provide them with the chatbot for the first time, the first thing that they did is exactly trying to ask for simplifications for certain concepts from some certain papers about, let's say, in that case was about eggs and how eggs are basically stored in particular places, pre-processed, whatever. And I mean, the LLMs were doing a decent job to explain it in a more simpler way, but again, general. So sometimes you have a knowledge that is limited, and the model needs to know what you know in order to be able to explain that. I hope that makes some sense, because it's a little abstract in a way. But we see that a lot with our clients, and we're looking forward for the future where actually we'll be getting these personalized AI assistants in our pockets that can explain us very complex phenomena that are happening around us to the very detail, maybe of even the materials or what temperature they are made, what happens, but in a language that's actually easy to understand from our side. So here there are more or less a bit of a summary of these kind of instruments that you have in order to do tailoring today. As I said, personalization is still a bit on the verge. It will be coming maybe in next months or years. But when it comes to tailoring, you have the ability to do prompt guidance, as we showed with the graphs. You have the ability to do a multi-shot questions, or in order to get to your question, you can ask the LLM, for example, tell me something about this material. Then after that, you can ask the model to actually generate 2, 3, 4 answers. Then you can ask it to rank them, maybe select the first one. I mean, this essentially requires a few shots, but it still can work. I mean, there are research articles that are showing good results on that. The problem there is that those are quite sensitive to the prompts, so you have to be mindful of that. Like probably all of, or most of us have heard about this RAGAS framework. It is very powerful, but the important thing there are the prompts. So the prompts are not universal, so you have to figure out what prompts work for you in this multi-shot evaluation metrics. And then after that, we have fine-tuning. I mean, you can see that things can become a bit more expensive. So fine-tuning is more expensive, then more tokens have to go through the model in order for it to start understanding things. Still, that can be very useful with synthetic data generated from structural and non-structural knowledge. And I can talk a lot about that. So if people are interested in these techniques that I just show you are very simple but very powerful. Additionally, then we go after fine-tuning, there is additional pre-training. People will say, okay, so why would you need to do continuous pre-training for a model that has already been pre-trained for several epochs by like the top companies in the world? Well, one of the use cases here is, for example, for language tailoring. If you want to get better answers on a particular language, and the model is not trained, or in the training data there is not enough language tokens, then you need to do this continuous pre-training, because the model needs to understand better the language constructs related to the particular language. So that's one situation in which you might do that. And yeah, there's a whole new topic about this. But yeah, so if you want to tailor stuff to another language, you have to go more or less through continuous pre-training, fine-tuning, and so forth, depending on your task. So I mean, this continuous pre-training is for tasks that requires native answers. So for example, when you teach kids and you let kids interact, or when you go into a sensitive domains, like for example, medical care or something like that, where you need to explain things to people very precisely, because otherwise they might be scared, or yeah, they might have panic attacks or whatever. So, and then the final thing is training from scratch. That's probably so the least preferable option, because it's very expensive, but still there might be situations like, for example, we were thinking about having these science-based models that are trained on research articles, patents, textbooks, and stuff like that. But it's good that Microsoft took that job, because yeah, otherwise it's really expensive and really difficult. And even if we manage to gather the money to do just one epoch or maybe 2 epochs of training, that literally means that we should not have any mistake. So basically, everything should be perfect, and we just run it once and we pray that it runs, which will never happen. So so yeah, so that's something to consider here. But yeah, this is at least for today really expensive. And all these trainings today that happen in different levels, like we see models now 2 to 3 billion models, then we have 7 to 8, 13, 14, 70, and so forth. The really interesting thing is that people need to understand which models are good for their particular use case. Of course, the smaller ones are cheaper, but one of the interesting things about those is that even the smaller ones can learn a lot of interesting constructs, and they can be useful for your use case. But you should know one thing, that the smaller models have much less space for encoding knowledge. That means that if you really want a general model that knows the whole internet and can answer each and every question without any RAG system attached, then you shouldn't look for the smaller models, because they don't have the space, because they are learning other constructs. So space for knowledge is not there. So when you evaluate smaller models on the knowledge that is inside, you should have this thing in mind, that they have limited space. So if you go then to the larger models, there's a lot more space and things like that. Like one of the use cases that's very easy to grasp is if you try to train a model, let's say 7 billion model on 2 languages plus the English language, which it has initially, so 3 languages. You see that if you train it on just one additional language, like continuous pre-training, fine-tuning, things look okay, so it can speak the 2 languages. And when adding the 3rd language, is actually degrading all the 3 languages, because there's just no space more for encoded knowledge and constructs on different languages. But then if you go to larger models, you can see that these things work. Yeah, just wanted to share that. What else do I have? Yeah, so finally, maybe this is more of a summary of the talk. What we want to do essentially at Iris is unlock the frontier of future discoveries. And we believe that this can happen with personalized agents and question and answering interfaces. The beginning are these chat-like interfaces, but we believe that the systems of the future will have much more different ways of interacting, including still clicking around, doing stuff, talking, maybe gestures, maybe other things. And we can't wait to see this future, essentially. So yeah, that's it from me for today. I hope that was interesting. So yeah, any questions are welcome, and any discussions, comments afterwards as well too. So.